So the first thing that you want to do is we want to get the logarithm by itself. So this example of -2 times log base 9 of x, what can we do to get the logarithm by itself? How do we get rid of that -2 in front of the logarithm? Add it or divide it? What? Divide, right? So we're going to divide each side by -2, and that will get rid of the -2 in front. So then we'll have log base 9 of x equals, what is -2 divided by -2? +1. All right, so once the logarithm is by itself, then step 2, now what's the opposite of a logarithm that we talked about last week? Exponents, right? They're opposites of each other. So then to solve the logarithm equation is we are going to exponentiate, it's a funky word, exponentiate each side of the equation. Because we know what we do to one side of an equation, we must do to the other side, right? So what will happen is our equation will go into the exponent, okay, and the number, oh, I forgot to add one thing here. So bases must match or be equal to one another, okay? So what is the base of our logarithm we have here? What is the base of the log? 9, right? So then we want to exponentiate using 9 as the base of the exponent. So I'm just going to put a 9 here. Okay, so it'll be 9 to the power of log base 9 of x, and what I do to one side of the equation, I have to do the other. So then I'm going to put a 9 here below the 1. So now our equation goes to the exponents, and notice the number of our base matches the this of the log, right? Because 9 to the log base 9 power is 1. So that will cross out to be 1. And then we'll have whatever's after the logarithm, we'll have that left over. So that will just be x equals 9 to the first power, which is just 9. Okay? So we got the logarithm by itself, and then we exponentiate each side of the equation. So let's do another one. Oops. So number 2 here. -1 plus log base 4 of 6n equals 3. So here's our logarithm that we need to get alone. So we need to isolate that logarithm. What should we do first? Yes, add 1, right? So we want to add 1 to each side. And then that will be log base 4 of 6n equals 4. So now we have the logarithm by itself. Now we can exponentiate it with what number do we want as the base? 4, right? So it'll match the logarithm base. So then we go 4 to this power equals 4 to that power. So I just make the whole equation now be in the exponents, right? And 4 to the log base 4 power will cancel out to be 1. And what will we have left over? 6n. Good. So we have 6n equals 4 to the 4th power. We don't want to go 4 times 4 here. We want to go 4 to the 4th. Pretty sure that's 256. And if you don't have a calculator, will you guys grab one because you'll need one today? And then we will divide by 6 and just simplify that fraction, whatever that simplifies to be. I think you can just take half of each of those. So what does that simplify to be? Key in. Thank you. So 128 over 3, and that is our answer. Sorry. So we got the logarithm by itself, and then we exponentiated each side. Okay? Now, let's do one more type of logarithm equation. Oops. So what if we have log of x plus 4 equals log of 4 minus 3x? So what if it's an equation like this? So step 3 that I want to add up here is if you have a log equal to another logarithm, then you can cancel out the logarithms if they have the same base. So you have to have a logarithm equal to another logarithm. You couldn't have a log of something plus another log of something equals another log of something and cross them all out. You cannot do that. It has to be just a logarithm equal to another logarithm, and they have to have the same base number. So let's look at this example. First of all, what is the base of these two logarithms if it's not there? 10, right? 10. So we know they have the same number as the base, so now we can just cross out the logarithms. So cross them out and then solve for what's left. So then we'll have x plus 4 equals 4 minus 3x. And then, let's see, should we add the 3x over to the left side here? So we have a positive. Okay, so let's add the 3x. So then we'll have 4x's plus 4 equals 4. And then what do next? What should we do next? Subtract 4. So 4x equals 0. So therefore x equals 0. Good. Okay, so easy when it's logarithm equal to another logarithm. Cancel out the logarithm, solve from there. Okay, so that's how you solve logarithm equations. You get the log by itself and you exponentiate. Now let's do the opposite. Now let's do exponential equations. Okay, so this will be example number 4. Okay, if you have room, just keep adding to the same page. Otherwise, you can just go on to the next page. Not a big deal. Yes, ma'am. Back up here or that or this one. There's 6. There's 6. So if you need to go to the next page, that is fine. Because I did 3 of each. Okay. So exponentials. First step with an exponential equation. Yeah, but probably only to there, so you should have. Okay. All right, so step 1 with an exponential is you want to get the term Yep. Yes, if you run out of room, you're okay to go on to the next page. So, first step is you want to get the term with the variable in the exponent. So that's what makes it an exponential equation by itself. So get the term, the variable, and the exponent by itself. So do we have that for this example, 7 to the v power equals 11? Do we have that? Yes. So then, what's the opposite of exponential again? Starts with an L. Logarithm, right? They're opposites of each other. So then, step 2 is we want to take the logarithm of each side, and we want the base of the log to equal the base of our number. Okay, so the base of the logarithm needs to match the base of the number that has our variable. So what is the base of our number that has our variable in this one? 7, right? So then we are going to take the log base 7 of each side. So let's just write log base 7 of 7 to the v equals log base 7 of 11. So all we did is we just added log base 7 to each side of the equation, right? And why we want to do that, because remember last week we talked about, well, if we have log base 9 of 9, what is that always going to equal if these two numbers are the same? 1. Why? Why will it always be 1? Because that number to the first power will always equal itself, right? So that's why that always equals 1. So then when we set it up to where these match, then we can cross them out because it equals 1. So then we'll just have v equals log base 7 of 11. And then we just have to plug that into our calculators. So if you'll hit Control and then 10 to the x, that is the logarithm button. So Control 10 to the x, plug that in, and let's round to the thousandth place, which is 3 places. Log base 7 of 11 is 1 point, what? 2, let's go 2 more places though. So is it 2, 2, 3? Wait, what? 2, 3, 2. That's what it is? Okay. All right. Okay, 1.232. All right, let's do another one. So what if we have 20 to the v plus 1? So this is example number 5. So do we need to move the 1 over first? Yes, we have to get that alone. So we subtract 1 to each side, then we'll have 20 to the v power equals 42. Yeah, otherwise it's not an equation if you don't have the equal sign. Okay. All right, and then we want to take the log of base what? 20. So we're going to go log base 20 of 20 to the v equals log base 20 of 42. And what will happen to log base 20 of 20? What does that equal? Just 1. So I have v equals, and then we just plug that into our calculator. And let's round to the 3rd decimal place, which is the thousandths. 1.248. Oh, is it 247, then what's the next number? 6. So the 6 would make the 7 round up to 8. Okay? All right, one last problem. All right, let's do 11 to the negative 7a power equals 8. Nope, we are not writing any more steps. So, is the term with the variable by itself? It is, right? It has an operation in the exponent, but we'll figure out that after. But we're not adding or subtracting or multiplying anything to that, right? Is the term with the variable by itself? Right? We don't have like negative 5 plus this or anything, right? Okay, so then, what was that? You scared me. All right, so then we want to take the log of base what of each side? Log base 11 of 11 to the negative 7a equals log base 11 of 8. Yes. Yes, you do. Log base 11 of 11 is just 1. So then what will we have? Negative 7a equals log base 11 of 8. Don't plug that in yet, because now we can divide by negative 7. So now what you want to do is just plug in this entire problem in at once. Okay? So you can either do the fraction button, right? Enter it like that. Or once you put in the logarithm, make sure you arrow out of the parentheses after the 8 and then go divide by 7, negative 7. Okay? Don't do the divide by negative 7 in the parentheses of the logarithm, because that would be wrong. Okay? Yeah, negative, right? So it'll be a equals negative 0. What is it? I can't remember. Let's do 4 places this time, because your assignment actually does 4 decimal places. So it would be what? Good. Okay, let's practice some more on our assignment then. Okay. What you want to focus on is if it's an exponential equation, you want to take the logarithm. If it's a logarithm equation, you want to exponentiate. You have to think of what's opposite.